Hi friends, good morning. In the last session, I have conversion and costing. Having any queries in type conversions and costing? Okay, what are the type promotion rules in Java? Anyone tell me? What are the type promotion rules in Java? One of you, please. Unmute yourself and speak with me. What is the first rule? All byte, short, char operands are equal to integer one. Second one, if anyone is float, byte, short, char, all are promoted to int. Then the next two data types, what are they? Long. If anyone is long, the entire result is promoted to long. If anyone operand is float, a float plus something, the entire result is a type promoted to float type. And if anyone is double, the entire type is promoted to double. These are the type promotion rules in Java. Our next topic is arrays in Java. Today I have seen arrays in C and C++. Arrays are collection of a homogeneous type, same type, that is homogeneous collection of elements of a similar type. For example, if you want to declare 100 variables int x1, x2, x3, etc., x100, we need to declare the variables like this: x1, x2, x3, etc., x100 in C and C++ languages. Instead of having x1, x2, x3, etc., x99, x100, if we want to access a particular variable, it will be very difficult. So we can define it using a subscript int x of 100. Declaring so int x of 100, we can easily access the memory locations. For example, x of 0, x of 1, x of 2, etc., x of 99. So in total, 100 memory locations are accessible, starting from 0 to 99. Here, x is said to be the array name or a subscripted variable. X is a subscripted variable. X is a subscripted variable or an array. The indexes are indexes. Indices are indexes. 0, 1, 2, etc., 99. These are said to be indices or array indexes. Array indexes, these are positive integers. Here, 0 is also allowed. In C++, in case if you define int x of 5, all of the array elements x of 0, conveniently x of 1, x of 2, x of 3, etc., then x of 4, are all of integer type. In C and C++, once you declared an array int x of 5, this means that you do want to use the array x in 5 different memory locations. In case if you define x of 0 is equal to 1, x of 1 is equal to 2, x of 2 is equal to 3, x of 45 is equal to 45, x of 99 is equal to 99. This is a valid assignment in C and C++. X is an integer array having 5 memory locations. Having these assignments, x of 0 is 1, x of 1 is 2, x of 2 is 3, x of 45 is 45, and x of 99 is 99. This is valid in C and C++. Say yes or no. Is this a valid assignment or not?
Yes, sir. In C++, it is valid.
It's valid. Yeah, it's perfectly valid. Because here x of 5 in the sense that you need to declare only 5 memory locations. Conveniently, we are taking the memory locations 0, 1, 2, 3, 4. But here, you are instructing to the compiler to use the indices 0, 1, 2, 45, and 99. Any 5 memory locations are fixed by the user, perfectly valid. Subsequently, if you try to access, suppose x of 0, 1, 2, then x of 3 is equal to 3 means this results in error because already you have fixed 5 memory locations as 0, 1, 2, 3, sorry, 0, 1, 2, 45, and 99. You cannot access any other memory locations, indices, other than these indices once you have fixed and informed to the compiler. This is valid in C and C++ languages. C and C++ languages, this is valid. Where in Java, once you are declaring an array with array size, let it be array size, which defines the total number of elements in the array. Number of elements in the array. Once you defined the array size, then you must use the array indices only within the range of array indices. Okay, the range of array indices lies in between 0 to what one? Array size minus 1. 0 to array size minus 1. So declaring an integer array with 50 memory locations, array size is 50 means you can only access the indices from 0 to 50 minus 1, 0 to 49. In case if you try to access any other index out of this range, automatically Java throws this exception. Array index out of bounds exception. This is a built-in class. Array index, right? As the term implies, array index. The index of the array is exceeding the range, bounds exceeding the range. Actual range is 0 to array size minus 1. So you should be very careful in Java. This is the first difference from C, C++ to Java. In Java, array indices range lies in between 0 and array size minus 1. Out of this array index range, that results in a compile time error, array index out of bounds exception. So in this stage, what you have to do means you need to properly access the array indices from 0 to array size minus 1. Now let us see how to define a one-dimensional array in Java. Syntax to define a one-dimensional array. Data type, array name, then subscript. Then in the next step, array name is equal to new. New, what do you have to do?
New array name.
Array name is equal to new
Data type, new data type.
data type, then
Size
in
of
bracket
the
size of the array. Very good. Size of the array. Let us define array size. Try to write if you difficult to recall the syntax, is just to remember this way. Int x array is equal to new int of, given this is equivalent to a two-step process. Int x array, then x is equal to new int of 50. Both of these declaration statements are valid. Int x array is equal to new int of 50 or int x array as we did data type then array name and bracket then new int of 50. then array name is equal to new data type, the size of the array. This is most convenient to define the one-dimensional array. However, in both cases, the array X is created of an integer type. The accessible memory locations are x of 0, x of 1, x of 2, etc. X of last index is 49. X of 49 is the last memory location. In Java, you need to allocate a memory using the new operator. Allocate memory for the array locations or array elements using the new operator. Integer occupies 4 bytes in Java. So 50 into 4 bytes, 200 bytes memory is allocated in this array declaration. So once you define the array like this, you can access the array indices from the range 0 to 49, trying to access the range, trying to access the index out of the range that results in the exception, array index out of bounds exception. Understand? So once you defined an array, you can go for subsequent initialization similar to C and C++ languages. X of 0 is 0, x of 1 is 1, etc. X of 49 is 49. Or you can access using the control variable, say for loop control variable x of I. X of I is equal to I star I star I. It's a one-dimensional array. Now the important thing in the one-dimensional array is, right, whatever the data type here, integer, floating point, double, byte, short, int, long, right? In these numeric types, considering the numeric types, once you have defined an array, declared an array like this, all array elements are initialized to what one? In a numeric types, all array elements are initialized to 0. For example, int x array, x is equal to new int of 50 means clearly memory locations 0 to 49. Here, all array memory locations are initialized to a value 0. We can also set explicitly some initialization to the corresponding array locations. Now, let us see this code. Class array ex1, static public void main string, some arguments array. We have defined one integer array. Int x array is equal to new int of 10. This means x is one-dimensional integer array having 10 memory locations. So accessible indices are 0, 1, 2, 3, etc. 9. Clearly the accessible memory locations are x of 0, x of 1, etc. x of 9. This is even equivalent to a two-step process. Int x array, then subsequently you can have x is equal to new data type is int of 10. This is the alternate way, a two-step process. This is a simple step process. Having another array, y array, right? In this case, we like to initialize the array during the declaration statement itself without the new operator. In C and C++ languages, this kind of a declaration and initialization is permitted. There you can write int y of 5 or int y array is equal to 1, 2, 3, 4, 5 semicolon. Do not specify the size of the array, right? So by default, how many number of elements are there? That will be taken as the length of the array. 1, 2, 3, 4, 5. So the length of the array y is assumed to be 5. Y consists of 5 memory locations. Y of 0 is 100, y of 1 is 200, y of 2 is 300, y of 3 is 400, and y of 4 is 500. So in this case, the array declaration and initialization syntax is like this. Data type, then specify the array name. This is equal to initializers. Initializer should be separated by the comma operator. Here should not specify the size of the array. Understand or not? In array declaration and initialization process, you should not specify the size of the array. Now let us traverse the individual elements in the array. For example, here int x array is equal to new int of 10. The array elements are not initialized explicitly by the user. We do want to initialize means you can write the statement x of 1 is equal to something, x of 2 is equal to something, or you can use the generalization using the for loop x of I is equal to I plus 1, like that. So by default, since this is a numeric type, all array elements are initialized to 0 when the memory is allocated using the new operator. So for int I is equal to 0, here int I is equal to 0, I less than 10, I plus plus. I is a local variable with respect to a for loop. We are printing the value of x of I. X of I is plus x of I. Then another variable j, for into j is equal to 0, j less than 5, j plus plus. We do want to print the value of y of j. Let us check what is actually printed. File name is array ex1. So compile the file java c array ex1 dot java. And java array ex1. X of 0 is 0, x of 1 is 0, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7, x of 8, x of 9, x9. All these array elements are initialized to 0. Since this is the integer array, in the case of integer array, all array elements are initialized to 0, having the numeric types byte, short, int, long, float, double. All these array elements are initialized to 0. In case of the initialized array, y array, this is stored at 0th location in the array y. Y of 0, this is y of 1, 2, 3, and 4. Let us verify the result. Y of 0 is 100, y of 1, y of 2, y of 3, y of 4 is 500. In case if you are going to initialize the Boolean array, possible to define a Boolean array?
Sir,
Possible or not? Can we define a
sir,
Boolean array? Yes. How to define? For example, a Boolean B array is equal to new Boolean of say 25. Let us check the values of array B. For int I is equal to 0, I less than 25, I plus plus. System.out.println p of I is plus b of I. What will be printed in the array B array over the range of I is equal to 0 to 25? Can you predict?
0.
0. This is not a numeric type.
True or false?
This is true or false. By default, what is the value of a Boolean variable?
False.
True or false
True
only?
or
False.
false? Actually, in case of array initialization, false is printed. B of 0 is false, etc. B of 24 is false. So you have to understand that this is the Boolean initialization. When array elements are of Boolean type, all array elements are initialized to false. This is the default value. In case this is a character array, what will happen? Here this is the byte short, int long, float double, then boolean, and one more possibility, a character array. For example, character ch array is equal to new char of 25 having the same statement ch of I is equal to ch of I. Can you predict what will be the initialization for the default value stored in the character array? There is no such a default initializer given to the character array. ch0 is ch1 is right, so it seems that there is no default value, so you need to check it, right? uh, if you want, you can explicitly initialize the values. So as far as numeric types are concerned, when the array is constructed, all array elements are initialized to 0. And in case of Boolean array, when the array is constructed, all Boolean array elements are set to a value false. Having any queries? If you have any queries?
No, sir, all clear.
No, sir.
Okay. Let us check another code. Next one is a two-dimensional array in Java. Two-dimensional arrays are said to be a multi-dimensional arrays. In Java, we can also define a regular two-dimensional or regular multi-dimensional array and irregular multi-dimensional array. Two possibilities are there: regular shaped arrays and irregular shaped arrays. Regular shaped array is an array in which the column size of each row is the same. Column size of each row is the same. For example, first row consists of 25 columns. Second row consists of 25 columns. Third row consists of 25 columns. So number of columns is the same in each row. That is said to be a regular array. For example, in C and C++, you might have seen that int x of pi 3. What is the meaning? X is a two-dimensional array which consists of 5 rows and 3 columns. In this x of I comma 3, this is array of arrays, right? Array of array. So x of 0 is clearly the first one-dimensional array. The accessible locations of x of 0 are x of 0, 0, then x of 0, 1. Conveniently, we are representing x of 0. Likewise, x of 0, x of 1. Okay. X of 1 is the next one-dimensional array. The locations to be accessible are x of 1, 0, then x of 1, 1, x of 1, etc. The last one-dimensional array is assumed to be x of 4. This is the last one-dimensional array. The accessible elements are x of 4, 0, x of 4, 1, etc. x of 4, sorry, x of 4 0 4 1, then 4 2, x of 4. So totally 5 into 3, 15, 5 into 3, 15 memory locations are created. In a C and C++, this file is okay. We can also define and initialize, declare and initialize a two-dimensional array, right? Int X array, no size in the first dimension, no size in the second dimension. Then you can initialize, for example, 1, 2, 3 in set bracket. For example, int X array is equal to set bracket. I write 1, 2, 3, closing curly brace. Then second row 4, 5, 6, closing curly brace. Then 7, 8, 9, closing curly brace, semicolon. Now this is a two-dimensional array which consists of 3 rows and 3 columns. This is row number 1. Row number 1 initializer. For example, x00, x01, x02. And row 2 initializer, a 4, 5, 6. And the third one-dimensional array is the third row, 0, 1, 2. Actually, the second row. Here 7, 8, 9. This kind of declaration and initialization of a regular multi-dimensional array is also supported in Java. Now have a look into this example. Int X array dimension 1 size should be omitted. Second dimension size should be omitted. This is equal to new int of first dimension. Here you have to specify 5. Second dimension you have to specify 3. In which 5 rows and 3 columns, 15 elements are allocated. Memory is allocated for the integer array for 15 elements. The 15 into 4 bytes, 60 bytes memory is allocated. As usual, here the array index starts at 0. Since this is a two-dimensional array, the first index to be accessible is 0, 0. And the last index to be accessible is there 4, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, etc. Last row is 4, 0, 4, 1, 4. Totally 15 memory locations are allocated. This is a direct step to define a two-dimensional regular array. First dimension is missing here, second dimension is missing. Then here specify the row size and specify the column size. If not, this can be equivalent to even a two-step process. Int X array. Then next step what you have to do. As usual, we defined in a one-dimensional array. Then X array is equal to a new int of 5, 3. That is a two-step process. Instead of having a two-step process, better to have it in a single step. Int X array with the dimensions is equal to new int of first dimension and the second dimension. Actually, this array declaration, this can be defined like this. Int X array, both of these versions are same. But this is a multi-step process. Int X array, no dimensions. Dimension 1 is missing, dimension 2 is missing. This is equal to new int of 5. What is the second dimension? Second dimension, that is column size is missing. Column size is missing. So when the column size is missing, we can define the column size for the individual one-dimensional arrays in the subsequent declarations. X of 0 is actually the first one-dimensional array. Now the memory is allocated for the first one-dimensional array. X of 0 is equal to new int of 3. Then x of 1 is equal to new int of 3. X of 2 is equal to new int of 3. X of 3, the next one-dimensional array. X of 4, clearly this is the last one-dimensional array. We should not use any other indices other than the range 0 to 4 because this 5 indicates that row size is 5. Column size that you can fix it in the subsequent steps. That's what in Java arrays are completely dynamically allocated or dynamically created. Since the operator knew which allocates a memory at runtime, arrays are equivalent to dynamic arrays in Java, where in C and C++, you have to create an arrays using a static concept int x of 50, even dynamically using the arguments, right? The command line input arguments you can create. MLAC arrays can also be created, but where in Java, completely arrays are of a dynamic concept. So here x of 0 one dimensional array, x of 1 next one dimensional array, x of 4 the last one dimensional array. All these one dimensional arrays are allocated the fixed column size. Fixed column size is 3, 3, 3, 3, etc. 3. That's what this kind of array is said to be a regular array in Java. Subsequently, you can initialize the array entries x00, x01, x02, right? So by default, here also a multi-dimensional array and the data type is an integer one. All array elements are set to a value 0. Default initialization is permitted. Now consider another two-dimensional array into y array, dimension 1, dimension 2. This is for our case. You can also edit your declaration like this. Into y array. This is also a valid state. You need not leave spaces. Need not leave spaces. And here this is equal to. Now what is 10, 20, 30, 40, 50? This is the first row initializer or first one dimensional array initializer, and this is the second one dimensional array initializer, and this is the third one dimensional array initializer. Clearly the three one dimensional array initializers are provided here. In this case, do not specify the dimensions of the array. That is not allowable. So here clearly three rows, and in each row we are having the fixed number of columns 1, 2, 3, 4, 5. Here array size is 5, and here the column size of the array is 5. So this is an array, two-dimensional array, which initializes are 3 rows and 5 columns. 15 memory locations are initialized. Now let us check the result. For int I is equal to 0, I less than 5, I plus plus.
Excuse me, sir.
Yeah.
Sir, what will be the number of columns
Yes.
in that one, sir? That
Number of columns in
int x you have declared, no, sorry, int x of 5 and curly braces. This means
this one.
x of 0 is equals to new int. Yes, sir. In that, what will be the number of columns?
Number of columns. This is the number of columns. Here 3 indicates that the number of columns. 3 is a column size. Column size is 3. That means dynamically in the subsequent steps we can fix the column size. In case of regular arrays, you need to fix the same column size. That's what here x of 0 first one dimensional array. The accessible memory locations are x of 0, 0, x of 0, 1, x of 0, 2. Why? The column size is 3. Likewise, x10, x11, x12, etc. x40, x41, 42. 3 indicates the column size. Here 5 indicates the corresponding row size. 0 to 4. Here 3 means 0 to 2 memory locations.
For each row, we can arrange any elements. For
Now,
each element, we can.
yeah, for each row, that is the concept of for irregular arrays. We will see in the next example. For see, in case first row, right, if you want to have only one element, here you can put 1. Here 2, here 5, here 2, here 7. So in that case, each row is of having different column sizes, right? So in that case, you can have the sparse matrix. So in some applications, for sparse matrices, most of the array elements are 0, need not be represented, right? In that stage, irregular arrays are used. Now let us print the content of x and y. Here x is printed. Similar to that, if you put for y array, contents of y are printed. For example, y is also of same size, 5 rows and 3 columns. Oh, sorry, how many number of rows? So 3 rows and 5 columns. So 3 here, 5. Java C array x 2 dot Java. Java array x2. This is the output. Here we are printing the results in the form of I and j. I plus, so j plus colon j, yeah, I j and
Change,
xi
we have to
j.
change I and J here also.
Pardon?
We have to change I and J,
Can't
no,
get
sir.
you.
In that before for loop. Yes, sir. In that only. I is less than 3 and J is less than 5. There only, sir. Below 3R and 5C you have written, no, sir.
For
Below that.
array y, yeah, 0, I less than 3, j less than 5. 3 rows and 5 columns. Let us check the results. First, for array x 0 0 0 1 0 2 1 0 1 1 1 2 2 0 2 1 2 2 3 0 3 1 3 2 4 0 4 1 4 2. Then that's all, right? Totally 15 memory elements are initialized to 0. And for the second array y, size is not fixed, right? So by default, based on the initialization, it is assumed for 3 rows and 5 columns. Row size is 3, column size is 5. 100, 200, 300, 400. Then what happens? 60, 70, 80, 90, 100. 60, 70, 80, 90, 100. Then last row. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is it okay? Is the result correct or not? Say yes or no. I plus j, y, I, j. 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, okay, 2, 3 and 2, 4, right? 2, 4 is 5. 2, 4 is 5. Yeah, the result is correct on last row. 1, 2, 3, 4, 5 is correct. This is said to be a multi-dimensional array in which the column size of each row is fixed. That is said to be a regular multi-dimensional array. See the next example. This is a irregular two-dimensional array in which the column size of each row is varying. For example, int x array, a two-dimensional array, is equal to new int of 5 and the column size is missing. This means that, what is the meaning? Row size is 5. Row size is 5 and the column size is missing. We can set the column size in the subsequent rows when the arrays are allocated a memory. X of 0, the first one-dimensional array, allocating a memory here for only one element, new int of 1. That means the accessible index is 0, 0, x of 0, 0, since only for one element memory is allocated. And x of 1 is equal to new int of 2. In this case, the next one-dimensional array, which is allocated for two elements. The indices are 1, 0 and 1, 1. X of 2 is equal to new int of 3 means the accessible memory locations are x20, x21 and x22. And x of 3 is equal to new int of 4 means x30, x31, x32, x33. X of 4 is equal to new int of 5, and for the last one dimensional array, 5 memory locations are allocated: 40, 41, 42, 43, 4. If you are printing the value, what happens? You will get the 0 initializer. Having any queries in this? This is to be the irregular two-dimensional array. The column size of each row is varying. That means dynamically you can set the column size for each row. This is not the same as a regular shaped multi-dimensional array. That's what this is to be, the irregular two-dimensional array. Having any queries?
No, sir.
Okay. How can you find the length of the array? Here we are trying to find the length of the array. System.out.println length of X array is plus what to do?
Sir, method, sir.
X dot
What is
length,
the
sir.
method to be called?
Dot
X
length.
dot length. Okay. X dot length. Is it correct?
Yes,
Let us
sir.
check. Array x3. Okay. Array x3 dot Java. Java array ex3. The length of the X array is 5. X array, right? Length is 5, right? 5 rows. Understand or not? Row size length 5 is obtained. Even if it is a one-dimensional array, int X array is equal to, for example, here int char ch array is equal to new char of 1000. Ch array length is ch dot length. The length of the ch array is 1000. So you need not traverse the array elements. How many elements are there, right? You can directly find using the length method, right? Ch dot length. Ch dot length normally it returns the length of the character array. Because in Java, we have to understand that two important fields. Java is a collection of packages, right? And interfaces. A collection of classes and interfaces are said to be a package. Collection of packages and modules, you can say. Java is a combination of packages and modules. One important package is java.lang, the language package. Java.lang, in which you can find one class. Class is a built-in class available in Java's language package. And we can find out one important class is object. Object is the super class of all other classes in Java. Object is a super class of all other classes in Java. So all other classes are user-defined classes that you are going to define, right? Or all come under the category of subclass of a super class called object. So here using the super class facility, right? you need not find out or you need not separately define the code to find out the length of the array. You can call the features available in the superclass, right? Since all our user defined classes are subclasses of a superclass called object, right? So you can directly access the length using the array name ch dot length. Next thing, I like to ask you one query in the same example. I like to initialize x of 0010 20304044, right? Up to these, right? How many memory locations? 15 elements, right? In this case, 15 elements are assigned. I like to assign x 55 is equal to 25. In the first example, I think in array x1.java, I have said that accessing any index outside the range of the array size results in results in a compile time error.
Array bound out.
Yeah, array index out of bounds
Array bound.
exception. That
Array
stage
index
I have
out of bounds.
out of array index. Yeah, array index out of bounds exception, and it results in compile time error. Is it? I have said here x of 3 is equal to 3. Uh, for example, in Java here, that results in a compile time error, assuming the array index is out of bounds. Is this true? None of you have answered.
Sir, it's
You
not
didn't
for me,
raise
sir.
any query. Yeah, for my statement, right? I have said that the statement, for example, int x array is equal to new int of 25. Accessing any index outside the range of x that results in a compile time error. I have recalled that. I have said that, but none of you have raised the query. How the compiler right checks if the array index is out of bounds? So is it possible to raise a compile time error? Compiling. No compile time error is reported. So understand that when you specify any array index that is out of range, what will happen means array index out of bounds exception is raised. Array index out of bounds exception means this is a runtime error, not a compile time error. Understand? Exception means runtime error. So array index out of bounds runtime error is actually the result. So during the compile time, in this case, when the array index is out of the range, no compile time error is reported. So that's what here, no compile time error. Let us run the code Java array x3. So you can see the runtime error. Exception in thread, right? Thread means single flow of execution. Main java.lang.array index out of bounds exception 5 at. This indicates that, right? The 5 array index 5. Array index is 5. We are accessing the index value 5 outside the range. Then uh, at array x3 dot main, which indicates that inside the main method we are having this runtime error array x3 dot java dot 19. Of course you can find the line number is 19, right? Starting from here, this is line number 1. In the 50 sorry, in the 19th line number we are finding the value, right? The runtime error state. So clear, when the array index is out of bounds, no compile time error is reported, but the Java interpreter reports the array index is out of range. So runtime error is there. Having any other queries? So multi-dimensional regular arrays are possible in Java, and multi-dimensional irregular arrays are also possible in Java. Another one is you try to learn some new concept which is supported after JDK 10 including JDK 10. Type inference with local variables. This is, of course, a strange concept supported in the latest versions of JDK, starting from 10. In Java, right, you know that whenever you want to use a variable, the variable first, it must be declared. Suppose x is equal to 25 means the variable x must be declared. Second, the variable can also be initialized, right, during the declaration statement itself. For example, int strength is equal to 120 semicolon. Strength is the integer variable and it is declared as an integer type and assigned to a value 120. There are some situations in which you need not declare the variable as int, float, character, double, like that, right? So in those situations, what you can do means you can declare the variable as uh, type inference local variable. For that purpose, right, what we have to do means you need to use one of the reserved word in Java called var, var. Var serves for different purposes. That's what I say. It seems a strange concept in Java. See this how var is going to access different things in Java. Var is actually a reserved type name. This is not a keyword, but this is a context sensitive identifier, right? The syntax to use a var is like this: var variable name is equal to value. So declaring var variable name is equal to value means by default, based on the value of this one, the variable name is assuming the data type. For example, I consider this statement: var pi is equal to 3.14159. Normally to declare 3.14159, right, we need to use the double type. And a double variable, say pi, can be initialized during the declaration and initialization. Double pi is equal to 3.14159. So having var pi is equal to 3.14159 semicolon means pi is right defined a float, sorry, double variable because of 3.14159 is a double type. Here, the context sensitive identifier var performs a rule to declare a variable pi as a double type one. Second example, int var is equal to 1000. In this case, var is simply a user-defined identifier with the type int. That's what I said. Var is not a keyword in Java. In case if it is a keyword, that cannot be used for identifiers, classes, right, to name methods, etc. Here, var, right, simply acting as one variable. This is equivalent to int x is equal to 1000, int y is equal to 1000. Now int var is equal to 1000 means normally here var is a variable which is of user, var is a user defined variable which is of the integer data type. Third example, var pi is equal to 3.14159. Here pi is a double variable and int var is equal to 1000. In this case, var is a user defined variable which is assigning a value 1000. Do not confuse this context sensitive identifier here with this user defined variable. Subsequently, you can write var j is equal to minus var means now what happens? J is declared of minus var value. Minus var value means minus 1000. Minus 1000 is of an integer type, right? So in this case, var is acting as the integer variable. In this case, j holds a value minus 1000. That's what I said, right? A var behaves strange in different situations. You can also declare the array name, right? Using var context sensitive identifier. Var array name is equal to new int of 100. This is perfectly valid integer type array because here the type is integer 1. Array name is completely acting as the name of the array. This int indicates that this array name is of integer data type. In this case, array brackets should not be introduced. Very important point. There are several restrictions. var array name. Here bracket, right? Square bracket should not be introduced. This is a perfect valid declaration. In case if you use var square bracket array name or array name square bracket, even the square brackets and the array names, right, can be interchanged. Int x array, you see here, int x array is equal to new int of 10. This can also be written as int, after that square bracket, then space, array name x is equal to new int of 10. Array name and square brackets can be interchanged. Uh, Here also, right? If you are interchanging, for example, here this bracket with here, this results in error. Here also, you should not use square bracket in case of var array declaration statement. Likewise, here also var array name empty square brackets is equal to new int of 100. This is a incorrect var array declaration. Using var context sensitive identifier, you cannot initialize one dimensional or two dimensional or a multi-dimensional array. So var array name is equal to 1 comma 2 comma 3. This results in error. Then whenever you use a var variable, the variable must be initialized, right? Var context sensitive identifier must be used to initialize a variable. In this case, var maximum semicolon. What is maximum? Maximum is here nothing. The data type uh, it cannot be inferred because the value is not initialized to the variable maximum. This is incorrect. These are several restrictions when using the context sensitive identifier that cannot be used as a name of a class. Class name, right, usage is restricted. But here you can use it as a variable. Int var is equal to 1000. This is valid. Neither var nor the array name has brackets. Here, array name data should not have the brackets, square bracket. Cannot use the brackets on the left side of var array declaration. Here also, you cannot use the square array brackets in the left side. Var can be used to declare a variable only when that variable is initialized, like this one. Whenever a variable requires initialization, that stage only you can use var maximum is equal to 120 semicolon. Var can be used only to declare local variables, right? You need not have any concept for the global variables. Locally, you can use var to declare. Var cannot be used when declaring instance variables, right? Later you see class variables are said to be instance variables and method parameters or return types. In that case, var cannot be used. Another important thing, only one variable can be declared using var. Var pi is equal to 3.4159. If you want to declare another variable, you need to use separate statement. You cannot declare, for example, double pi is equal to 3.1459, comma, x is equal to 125.35, right? Multiple variables can be declared in this declaration, but here using var, only one variable needs to be declared and initialized. A variable cannot use null as an initializer. Null, right? A nullable reference. Once you are allocating the object, right? To deallocate its memory location, you can set its value to null. For example, int x array is equal to new int of 10. X of 0 is equal to null means the memory location of x of 0 is void, not possible to access x of 0. So nullable reference later you see. So you cannot assign any null value to the initializer of a var. Var maximum is equal to null. Not possible because null is not a data type, so that var cannot infer its data type. Some other restrictions, var variable being declared cannot be used by the initializer expression, right? Like this array initializer, where variable cannot be used. Cannot use var with an array initializer, right? The same thing. Cannot be used the name of the reference type, right? Interface name, enumeration name, annotation name, or generic type parameter, right? For these things, you cannot use var as the corresponding and name. Cannot be used to declare the exception type called by a catch statement. Later we will see the exception handling framework. The runtime error will be caught in the corresponding exception handler defined in the catch statement. There you cannot use var. lambda expressions, right, are method references, right? These are some advanced concepts. In that, right, cannot use the var to initialize something. These are several restrictions of using the var the keyword. With this, right, we are completing the arrays, right, type conversions and the costing, type inference with local variable, right, var, and a string concept, right, a string class, right, a string class which is defined in Java's language package. The string class defines several methods which are used to perform the straightforward code without the user defined code. You can use the methods of string class directly. For example, a string comparison, checking the equality, not equality, right? Finding the character at a specific position. For those, several methods are supported in the string class, which is defined in Java's language package. Having any queries?
Sir, in irregular arrays, should the first row always contain only one element, sir?
Not necessary in irregular array. First row. Uh, First row. It is not necessary to have exactly one element. It seems right. I have used 1, 2, 3, 4, 5. For example, here you can type 15. Here, for example, 22. Here 1. Uh, Here 50. You can use any number of column size for each of the one-dimensional array.
Okay.
The thing is, it must be the positive integer. You cannot use 0. X of 0 is equal to new int of 0, right? That is not possible. Array size must be the positive integer. In case if you are trying to write x of 1 is equal to new int of minus 22, no compile time error, understand? But during the runtime, you will get the error negative array size exception, like array index exception. Here, x of, for example, x of uh, 0 minus 2 is equal to 25. No compile time error will be, but during the runtime, you will get this exception. Negative array dot right size next word, right? So caps array size exception. Array index must be the positive integer. Runtime error is reported. Any other queries?
Sir, while calculating the length, only the length of number of arrays is displayed, sir. How can we count the number of elements, total number of elements in 2D array?
Total number of elements in the 2D array, if you want to find out, right, you have to think of finding the first dimension size, second dimension size, third dimension size that you need to think of, right? You try to check, right, what you need to write here so that the array length, right, should be specified for the individual arrays. If not, you try to check, right, the two-dimensional array x array dot length like this. You need to check it if it works. If not, what you have to do is the only solution is you need to find out the individual dimensions, first dimension size, second dimension size, etc. Last dimension size, and write the product, write star. That is the only solution. You try to check it. Then okay, thank you very much. We will discuss the next topic later in the next session.
Thank you, sir.
Thank you, sir. Thank you, sir.